Okej, to zaczniemy każdego prezentację. Pozwólcie, że przedstawię się na angielski, because our next presentation will be in English. So let me introduce Serhiy Kostyshyn. Serhiy is currently a software engineer in Nokia, but previously he has gained a lot of software engineering experience in many different companies across US, Silicon Valley, and also Europe. And today Serhiy will tell us something about how to manage complexity, how to deliver products quickly and successfully.
Cześć. Na lekcja będzie naprawdę po angielsku, ponieważ nie mówię jeszcze dobrze po polsku, ale proszę zadawać pytania na dowolnym języku i proszę też zadawać pytania w ciągu tej lekcji. To będzie interaktywne.
Tego można i w chińskim. Tak?
Można i w chińskim, jeżeli pan mówi chińsku. Będę odpowiadać po arabsku. Okay, your rapid delivery toolbox, this is the topic, but first I would like to ask you how many of you, or raise your hands if you're currently working on any software project, any capacity. Okay, and whose project is currently being used in production as you develop? And who is satisfied with the speed with which you can make changes to the project? Okay. So the two organizers can actually leave and wait for pizza. For everyone else, it's going to be, I think, quite relevant because we're going to talk about exactly that kind of projects that are still being actively developed. And I don't mean maintained, I mean developed, adding features, growing explosively as they are being used by users across the board. And the first question is why rapid? Why rapid delivery is so important? Very simply, because many companies have to work in highly competitive environments, and whoever ships feature who gets to the market first often wins the whole market. Or such is the basic assumption that many companies work under. And that is highly crucial, and that also means that you have to take a lot of risks, product risks, leaps of faith, but also smaller risks in terms of delivery. You don't have the luxury of testing out every single small change that you are making, and before you ship it to production, because if you do, there will be always someone who does not, and is lucky enough to ship feature that is functioning, and that they will overtake you. So that said, let's talk about, so you're taking risks, right? By shipping something that might not be entirely ready for the prime time. What kind of risk is that? Let's analyze it a little bit. So let's say that this is an ordinary day, it's 10 in the morning, and people are churning out code, deploying to production, and someone deploys a change to a critical place in your application. Let's say that you run an online store, and your only source of revenue is when people add items to their cart and check out and pay for it. And someone makes a change to the checkout process, and you can see that the checkout metrics start to go slowly down, they just crash to the ground. And at this point, you don't have a store anymore. And if there is a definition of a critical bug, then this is it. You know that it is critical because if you do not do nothing, do not do anything about it, then tomorrow you might as well stay at home because you have no business anymore. Luckily, someone notices it. They see there has been a recent commit that says something, check out something. So they think maybe it has caused this issue. They roll it back. They deploy it, and the metrics start to recover. And at this point, you don't have this critical issue. So far, so good for the technical part. What from the business point of view? The first question that the business will ask you here is how much of daily revenue have you lost? So the whole outage lasted for about half an hour, give or take. And if we assume the users are active for, let's say, 10 hours a day, on average, then it means that we've lost about 5% of our revenue for that. So let's write it down. Now the next question, how much would it cost to prevent? Because okay, we have pocketed 95% of revenue, but we still do not want to lose those 5% without a good fight. So we are setting out and preventing those issues from happening ever again. So let's see, how much would it cost to prevent? We don't want engineers to push the changes as soon as they develop it to production. So let's perhaps add a QA engineer who would test those changes first. So an engineer would now make the changes, click through, see that it kind of works, but then instead of pushing it to continuous integration, to deployment, they would hand it off to a QA engineer. QA engineer would test it that day, maybe next day. Then there would be someone who would do integration testing again, maybe next day, maybe next week, and then sooner or later it will end up in production. I don't know if you see problems about it. First problem that I see is the ratio of QA engineers to software engineers kind of different. The last time I checked, it was in many companies about 1 to 2, 1 QA engineer for 2 software engineers. So if we are to increase the number of our engineering employees by 50%, it would cost us some money, and I don't know how much, but certainly more than those 5% that we are intended to save. And as I mentioned, there are also costs in slowing down the entire process. Because the feature that would have otherwise gone to production today will have to wait a couple of days, maybe till the next week, and you will lose this kind of momentum a lot. And also, there will be some new merge conflicts when you finally end up merging that feature, and so on. So you will also lose some speed of your development, of your delivery. How much? It will depend very much, or to a large extent, on how rich your organization is. Let's say it's anywhere between 10 to 50%. So once you look at these numbers, you lost 5%. This is the cost for hopefully preventing it. And obviously, I'm oversimplifying it, but let's say that it is. The question that business will ask at this point, is it worth preventing? And by worth, what they mean is, very strictly, is it financially worth preventing? Now, if you think about it, it's always a kind of this balancing act between prevention and reaction. To prevent, you need to put more effort into designing it better, testing it better. For reaction, you will have to spend more time on monitoring to detect these issues earlier and preparing to react to them. In practice, any practical organization will do both parts. It's just a question of, as I said, the balance. And I would argue that if you like to move fast, your balance would be shifted towards that way. Less of prevention, more towards reaction, for the reason that I just shown. So let us see what kind of engineering management side actions and practices will help you both prevent and react. So first, general practices. Continuous deployment. Continuous deployment is, I would like to put it front and center because it is key to many other practices that I will describe later. And they would be far less efficient and impossible about it. Also, it has values, high value in itself. First, it's faster turnaround because as soon as you finish developing the feature, it's out. You might have 10, 20, 50 production deployments every day. So features do not just lay around. First, it will lower your risks. Is anyone curious about why it lower the risk, not increase the risks? Does anyone think this kind of doubtful that it will lower your risks? Anyone?
Because for small time, it's has ability to make some bigger change, so we can simply go back to the previous stage.
Yes. Right. So in practical terms, obviously, if you ship without testing, it might seem that the risk of each single change will increase, and that might be true. But if you instead of shipping 10 changes every day, you batch them up, you ship 50 changes once a week, or 100 changes once every 2 weeks, and then something crashes, like in the website, what do? Good luck figuring out which of them had caused this. So what do? Do you revert all the changes for the 2 weeks and then start digging in? Or how? You allow your website to stay down while you are investigating? Neither of this is perfect. When you do continuous deployment, you see, okay, this didn't work, let's roll it back. It doesn't take much time, and how much time it should take, we'll return to this question later. So actually, overall, it will lower your deliveries. And the last one, which is super important, is higher confidence. Because if you know that your website is being deployed 10 times every single day, that the engineers know that your deployment pipeline works, your testing, what you do works, and develop. You will still do developer testing, right? I will not, depending on the developer, but I will not push something to production without testing at least the golden paths, maybe a couple of edge cases. It will depend on the complexity and the risk, right? You will still do some testing. Second, unified technical stack. I have worked on a project that was exclusively Python. We had 10 services, and then the senior architect that was mentioned in the previous speech, the senior architect who was in charge of this project decided that he wanted to put Go in his resume. Go was a whole rage. It was 2011 maybe. So for a new service that we needed to create, he wrote it in Go. Then he left. We took over, and so we had this deployment machine that was geared towards Python, and we had a small deployment machine that was doing the same thing with Go. And we had to learn Go additionally. What we did, we rewrote this service into Python at the first opportunity, and before we had to make significant changes to it. So unified technical stack makes it easier for, first, it should be the default for new development in your project. So it should be one stack or a couple of stacks, which if you have, let's say, mobile and web and something else, then obviously we'll need a couple of them. It makes it easier to switch between projects, both for engineers. Let's say I'm a bit tired, I'm starting to burn out on my current project, I would like to switch. It would make it easier if I don't have to learn a new language. I would still need to learn a lot about the architecture itself, but not a new language. Or business, if a business decides suddenly that we want to have all hands on this feature and we deprioritize this feature, then it makes it easier to take a couple of engineers from here and put them in here and not spend extra weeks or months on getting them up to speed with technology. This gives rise to deeper knowledge of the given stack and increased efficiency. Better code reviews, faster, and less buggy code and so on. Managing technical debt is another big thing. Maciej Triniarz actually had his talk, 50 Shades of Code, I think 3 meetings ago. And I owe this presentation to him because it is kind of a follow-up on his thoughts. He was approaching more from the project management perspective and a bit of technical. And this, you can think about this talk as an expansion towards the engineering management side. So key focus of his speech was on managing complexity and managing technical debt. I will not therefore I will not talk a lot about it. I can say that it has to be done because the projects tend to grow larger, the code base tends to grow larger. The knowledge that is embedded in the lines of code and curly braces gets more numerous and more advanced. So you have to take active steps to cut down on complexity. The mindset of Kaizen is one thing that will help you. It's a kind of fancy word for your for your continuous improvement and initiative that goes from bottom to top, not from the management, but from each engineer. If I see that this doesn't look right, this is not efficient, or this doesn't scale, excuse me, I can take this opportunity to, let's say, create a ticket, discuss with the team, get it into sprint, and fix it whenever the priorities allow. And this is necessary. Another thing that you can do, limiting latency, especially in customer-facing projects, is very important for user interactions. Also, in any projects that have multiple services that use databases and which don't, remind me. So the managing latency is important because it allows you to scale better, to handle more peak loads, and generally it keeps you kind of autonomous in terms of optimizing your queries, your turnaround of your services. And fixed sprints, if you have just too many changes to make to fix something, you can dedicate specific weeks or sprints, or at least days, to fix the things that are on your backlog that would not otherwise get fixed. Knowledge sharing and combining. Knowledge sharing is a very popular phrase. Knowledge combining, not so much. I would argue that you need both. So first, you obviously will need to share knowledge across your organization, but when you get out to developing a new system, let's say, or a new service within your product, you would like an input from the most knowledgeable people from across your organization, right? You would like to combine this knowledge in some way. You could try talking to them face to face and discussing, and then but what happens then? You've set up you've kind of decided on the architecture, and then someone approaches you whom you didn't talk to and say, hey, I've heard you're going to change this, so I actually am dependent on this very heavily. So let's go over what you're going to do. And you're discussing again, you have to make changes and so on. It's simply not sustainable, not scalable. The best way to share knowledge is written in any organization of scale that is not one or two people, through design documents, RCs, whatever you call them. So you get an idea, you write them on Google Doc or whatever doc that you use. You share them across your organization, across engineering, or across a specific dedicated mailing list. You get inputs, you get people comment on that. And if you act on these commands, you discuss them, then in a matter of mere days, you will get a design that is ideal. And ideal in not some kind of abstract way. I'm not saying it's going to be perfect, but by ideal it means that it's going to be as good as the collective mind of your organization can make it. Think about it. How? Because when you ask for comments, most people obviously will not even open that email. They will not even read those documents. But if you will, and those few are exactly the people that you care about, because they will read you because they either depend on that functionality, are going to use this functionality, are going to integrate with that functionality, or simply have worked on this functionality or have some special interest in it. All those are categories of people who are motivated and know something about this. And this is again the people who we want to attract. So if you've collected the feedback in a proper way, you can argue that it is ideal with the definition that I've just given you. This implies open, broad discussions, consensus, and tech talks and demos are obviously a very good way to share the knowledge. This is an example of design doc that is, I believe, it originates from Google. It's for Chromium. It's probably a typical Google's design document. You cannot read it, that's intended, but you can see the table of contents, and you can see that 2/1 of these items are fully on screen. So it's not a long document. It doesn't have to be long. It has to just cover just enough. It doesn't have to be formal, like some structure and so on. That should be enough for many tasks that you are doing. Okay, if you engineer your progress in this is called Git flow. This is one way of organizing your branching and development process in Git. This picture is taken from a blog post from 2010. It went hugely popular, so much so that many companies just jumped on it, introduced this one. I work in one of these companies as the primary flow for their development. There are a couple of issues with this flow. First, as you might notice, that it is pretty complicated. It has all kinds of different branches that are permanent or semi-permanent. It generates a lot of merge-only commits, which make it difficult to track down. If you have an issue in your code, they make it difficult to track down what exactly caused that issue. You have to sift through all these changes that are not actually changes, that's just merges. And also, I would argue if you have continuous deployment, continuous integration, this is an overkill. For one, because in continuous integration, the difference between master and the staging or development is non-existent practically, and many other things. So if you're looking at this to introduce, then think again. An alternative would be what we call the linear commit history. This is it, more or less. It will make it easier for you to find an offending commit, if there is one, or a commit of interest for any reason. It will cause fewer merge conflicts for various reasons. I can discuss this separately, not to get too technical. A few magic spells that you will need for it is squash, rebase, and fast forward merge. Yes. Component ownership. Each component should be owned by a specific team, not a specific person, but a specific team in your company. And the list of those teams should be very easy to find. So that when, let's say, I want to add some functionality that affects, let's say, a search bar on my website, and I do not have to think twice, whom should I talk to about the search bar? I should be able to look it up and see, okay, this team, so I'll hear the contact information of the team, I'll send them a message, I'll talk to them, I'll send the code review to them, and be done. So that helps for concentrate the domain knowledge about a specific component in one team. You cannot do without it. Ideally, everyone should know about everything, but that's simply not possible. But component ownership will help with that. And if you have a design document that touches that search box, you know that you have to include that team that owns the search box in the design document. Person. Short sprints. Okay, how long are your sprints? Who has sprints that are 2 weeks long? Okay, 3 weeks? More than 3 weeks? 1 week? Okay, so everyone has 2 weeks, so it's pretty standard. I have worked at a company that has 1 week sprints. It might seem quite harsh, Because what can you do in 1 week? It turns out a lot. And it's a super effective way to motivate you to just ship, to get to done faster, to be more efficient about how you do about work, to discuss that backlog in advance, so that when the sprint starts, you do not open the ticket and think, okay, what do I need to do for this thing? You already know. You just get down to work. Short sprints, that will also help you limit work in progress. Let's say you have 10 tasks, you've done all of them by half. This, in total, from the business point of view, your value to the company is 0, because none of the tasks are ready to ship. If you prioritize differently, if you do 5 tasks and do not even touch 5, then you already brought your company significant value for the same time spent. So minimizing work in progress is very good, especially in the context of a fast-moving company and startup. Okay, minimizing risks. When we were talking about this outage, this bug that brought down our checkout process and our website, we said we have to react. There is no way to avoid it, but it doesn't mean that we do not have to minimize the chances, the likelihood that this will happen. We have to. And to minimize risk, we have a couple of excuse me. We have a couple of techniques. First, deployment and rollback. First, continuous deployment, as I mentioned, and the canarying process are great at seeing very early if something causes issues and only back immediately. The rollback criteria should be very simple, and for anyone observed. So when you push the code and starts deploying, ideally the person who pushed it should be observing what's going on, right? And they should have a very simple criteria in mind about what constitutes normal behavior and what not. So if the metrics go down a little bit, maybe that's fine. Maybe that's just noise. If significantly, you have to know that this is your cutoff, more or less. And once you've made the decision to roll back, it shouldn't take you more than a minute to initiate the rollback. There should be like, you made a decision. Now here's your checklist, or here's the button you have to click to roll back. Simple. Let's analyze this situation again. The first question for minimizing risk that we should ask ourselves here is, can we have reacted sooner in this case? So let's just analyze what has happened. So by this point, it should have become obvious to anyone observing that the website is not healthy. Something's going on. Maybe some automatic alerts should have gone off. The person who is deploying should have been tracking the metrics, and definitely by this point they should have noticed that something's wrong. Obviously, there's some delay in metrics. That's fine, but we're talking about principles here. So if they make a decision here to roll back, and as I said, the initiation rollback procedure should be nearly instantaneous, then since there's still probably a canarying process going on because we have not lost all the traffic, then here rolling back would mean just reverting the canarying process. So there is old code still deployed on servers. You just have to direct more traffic to that old code, and the incident will be over much faster than here. So definitely the recovery, the rollback procedure should have started before this metric hit the floor. So instead of this roughly 20 minutes of complete outage between the time it was obvious and time when the actual rollback started, we would have had maybe a couple of minutes, maybe 5 minutes in practice. What it translates to this, that the cost of this outage will be, let's say, half what it had been previously if we have minimized risks properly. What does it mean? It means that we can make twice as many mistakes now for the same money. Or if you wish, move twice as fast for the same money, taking the same risks. All that we have to do for that is just introduce some tiny procedures which are very reasonable to our deployment process. Nothing more drastic than that. And we already would get an improvement and would let us move faster. Break or non-breaking changes, another key thing in minimizing risks. Feature flags. How many of you have heard of feature flags? Okay, 4 people. How many of you have used feature flags? Or have the team use feature flags? Okay, 4 people. Very good. Feature flags are an amazingly effective means of minimizing risks for the amazing simplicity. Essentially, a feature flag is just a checkbox in your admin tool or wherever, that says whether the feature is on or off. So let's say I'm developing a feature, I'm going to integrate with a new third-party website, third-party API. So I'm making some requests, I've tested it manually, right? I can see that it handles whatever the server returns to me. But when I put it into production, I cannot be sure that that API will not return me once instead of like HTTP 200 and JSON, it will not return me HTTP 500 and HTML describing that error message. And this is kind of an in-joke among engineers about error HTML in APIs. And it's difficult to predict it. You cannot control it. What you can do though is put this feature behind a feature flag. So when you deploy it, initially it's turned off. So no requests have been made to the party service. It just works just like before. When you turn it on and your website suddenly starts crashing, every 10th request, let's say, over every 1,000th request which you could not have possibly predicted, your recovery procedure is that simple. You just switch off the tag. And then you look at the logs, debug it, take whatever time you need, fix it, deploy again, turn on again, it works. Fine. This is an amazingly powerful feature. And one of the projects that we have run dozens of feature flags in parallel. They have their own issues, but that's a separate thing. Minimum risk migration, especially in the persistence layer in the database. Example: let's say you want to migrate from MySQL database to HBase. How do you do that? So obviously you have to migrate the data. You have to have some code that reads and writes to the database. You have to confirm that they are working correctly, all of them. And then you deploy it. You turn on, let's say, you turn on the feature flag, and basically what you do next, you pray that it doesn't crash. Because what you've done is just you've done a high-risk action. You've instantaneously turned off one thing and turned on another thing that is critical. If there are issues, then you can turn them off, but the data that has been written to the new database, meanwhile, not written to the old database, is already an issue. So how to avoid it is through things like double reading, double writing, and shadow execution. What you do instead to minimize risks to zero, almost zero in this case, is you put up both databases, you put them both on production. When you write to the database, you write to both databases at the same time in production. Then when you read from the database, you again read from both databases, you compare the results, you log the differences somewhere, then you discard the data from the new database and return the data from the old database. That way, no user behavior is changed at all. But after you run this in such a way for a couple of days or weeks, you can be sure that they behave exactly the same. There are no discrepancies whatsoever. Second, you have proven that your new database can work in production. It has, in fact, handled the same production load that your existing database. So when you then make the switch, and the switch will, again, it is double reading, then after comparison, you will return the new database result, discard the old database results. This is it. Your migration has been successful. What you need to do now is clean up, drop the old database, and that's it. The risk is 0. It will also allow you to move fast because it's less of you will spend less time on this testing. Okay, that's all for gradual non-breaking changes. Monitoring, this is a screenshot from Grafana, which is a popular monitoring tool. You probably have it, you should have it. Monitoring, you will have dashboards. The dashboards should be owned by the same team that own the components that are being monitored, not by SREs exclusively, or DevOps or whatever, because the team who develops the feature is best positioned to say if what they see on the dashboard is in fact correct. Is it okay? Or is it time to kind of cause some alarm? Also, if they make changes to the code, they will be able to make the same changes or corresponding changes to the dashboard. There is no disconnect between that. Not someone just seeing something weird and not knowing where it came from. This is the same team. They say, okay, this is the new thing. Let's add it to the dashboard. And alerts. If you're serious about SLAs, you will have alerts, you will have on-call rotation. Incident preparedness and response. This is the last section. So as I have said, despite all this prevention and minimization, you will have bugs. You will have critical production issues, because if you don't, then you should. Because if you don't, it means only one thing, as I said, that you're probably moving too slow. Someone who is more willing to take risks will eat your cake. And that's it. So you will have production issues. You will have them often. You should. So how do you prepare and respond to them happening? Preparedness. Component ownership, as I had mentioned. I can see that I went to the website. I can see that the search box is not working at all. Somehow it wasn't picked up by alerts or whatever. So I should have a simple way to look it up, to look at documents, to see, okay, this is owned by this team, and here are their emergency contacts. So I just fire them the quick email or Slack message or whatever, and they are on it. And on-call rotation, escalations obviously necessary, because with our person, we are humans. With our person is on call, can go to shower, can sleep, can turn off their phone, and it should be escalated to someone else on the team soon. Instant response. You will have issues. So first thing in incident response is feature flags. As I had mentioned, if you have feature flag, if you had kind of forecasted that this feature might cause issues and you have put it behind the feature flag, then this is your answer to this incident. You turn it off and the incident is over. Of course, you should not rely on feature flags as a primary way to manage incidents, because that's sloppy. That will not get you anywhere in the long run, but it is useful. And I have added, in my practice, I have added feature flags just in case to new significant chunks of code that I didn't ever anticipate to cause issues, just because it is so easy to add them and to make it so easy to react to an issue, to a production issue. War room is basically a way to cut down on communication, especially in cases of bugs that it is difficult to determine their origin for. Unfortunately, not all bugs are. It is so easy to tie to a specific recent commit. That's unfortunately that's not always the case. Sometimes the bugs are really complex, and you really don't know what's going on. You keep discussing it on Slack for 10 minutes, 20 minutes, and no one has any idea. So the best way is to get people physically in the same room. Let's call it war room, and it's the most efficient way you can do to remove this communication overhead. So someone has an idea, they can walk over to someone else, look over their shoulder, and so on. That's the best way to deal with especially difficult production issues. And postmortems. Every significant production issue is an opportunity for you to learn. And basically, even though you will have issues, it should be your goal to never have the same issue twice. Right? You probably should you know that. I don't have to remind you, but postmortems is the way to ensure that. The goal is to prevent this kind of issues from happening again. The explicit non-goal would be to blame someone for those issues. Usually postmortems, it's best to approach them the same way that you approach design docs. You write them down. You start writing them down soon after the incident is over. Let's say, okay, you decide recovered, you took a fresh breath, you stepped out for coffee, you got back, you start writing the postmortem. And usually the best person for the postmortem, to own the postmortem, is the people who know the most, which is another way of saying the people who have caused that issue. Because they objectively know the most, second, they are interested, they have skilled interest in this, and third, and more subjectively, is kind of a moment of catharsis from you if you've caused the issue and then you've helped resolve it. That should not be the rule, of course. That's not an excuse that I own the postmortem so I can make more of these issues. But I have seen people who have owned a major postmortem every month, every 2 months, and not only they were not fired from the company, they were in fact some of the most valuable engineers in the company. And because the whole reason they owned postmortem is because they worked on such critical parts of the code where in complicated parts of the code where any change was inherently risky. So they made the changes. Most of the time they would succeed. Sometimes they would fail, and they would go open postmortem. So there is nothing bad about it. It's an opportunity to learn. So let's put it all together. First, remember that it's essentially always a balancing act from the point of business, from the viewpoint of business, on how much effort you would like to spend on preventing issues versus reacting to them. Obviously, if you're working in developing a system that has anything to do with human lives or automatic stock trading, probably you would like to spend a lot more time on prevention. For the most of us, luckily, we have the luxury of making really that trade-off based on our business needs. And this is the list of things that you might need. Everything we've discussed so far split under general engineering practices, specifically minimizing risks, and specifically responding to issues. Okay, and now if you have any questions, I'll be happy to answer. Or you can make comments. Okay, I have a question for you. Who uses all of these items in your daily work? Or like all of them except, let's say, 2 of them. Who uses half of this in daily work? Okay, who uses a quarter of this in daily work?
Give us the time to read.
Huh?
Give us the time to read this. Okay?
This is all that we've discussed.
Okay.
This is all that I've covered.
I'm counting.
Roughly, I know that. Here, the speed, the speed is more important than precision. So, if you don't if you don't use it, maybe you don't feel the need for it. Maybe you're not so much down the path of kind of really focusing on prioritizing and prevention or reaction to the issues. I have some companies that use all of them, or most of them. I have some companies that use almost none. So it will always depend on your domain and the maturity of the company and maturity of the project. Okay.
I think I use the war room constantly.
Use the war room constantly, but I use any other techniques?
No.
Okay. You see the problem, right? Probably you're not approaching it from the right side. Okay, thank you. I'll be around if you want to ask any more questions.
Dziękujemy za tę prezentację. Zapraszamy teraz na poczęstunek. Część techniczna już jest skończona. Poczęstunek będzie po drugiej stronie koło napojów.
Zapraszam również do